Rodney Adams to the main office, please. Rodney Adams to the main office.
Hello, class. Today we're going to learn about rational exponents. We've learned about this radical notation, so today we're going to learn another way to express that same idea. So, for example, if we have the square root of x, another way we could write that would be x to the 1/2 power. Similarly, if we wanted the cube root of x, we could write x to the 1/3 power. The fourth root of x would be x to the 1/4 power. The fifth root of x, x to the 1/5 power. So kind of in general form, the nth root of x would be x to the 1/n power. One thing that this is useful for is in your calculator, you have a square root button, but you don't have like a cube root button, fourth root button, fifth root button. So using these fractional powers can help you do that same operation. So let's look at some examples. 125 to the 1/3 power. 125 to the 1/3 power. Recall that's just the same as saying the cube root of 125. These are the same, just different notations. So we know that 5 cubed equals 125. So 125 to the 1/3 power would be 5. Now what about 27 to the 2/3 power? 27 to the 2/3 power. So we could think of this as the cube root of 27. That would be 27 to the 1/3 power.
Armstead to the main office, please.
That would be 27 to the 1/3 power. And then if we squared that, that would be 27 to the 2/3 power. So we know the cube root of 27 would be 3. So if we squared that, that would be 9. So 27 to the 2/3 power must be 9. A few more examples. I'm going to rewrite these just in case the camera isn't quite picking these up. 4 to the negative 2.5 power. So one thing we could do is convert that decimal to a fraction. We could say 4 to the negative 5/2. And then remember, negative power kind of means to do the inverse. So we can say 1/4 to the 5/2 power. Which would be 1 to the 5/2 divided by 4 to the 5/2. And then we can think of that as the square root of 1 to the 5th and the square root of 4 to the 5th power. So this would obviously be 1. The square root of 4 is 2. 2, 4, 8, 16, 32. So 4 to the negative 2.5 power would be 1/32. Okay, what about negative 32 to the 3/5 power? Negative 32 to the 3/5 power. Okay, so again, we could think of this as the fifth root of negative 32, and then take that and cube it. So the fifth root of negative 32, if we recall if we recall odd indexes of negative numbers are possible. If we took negative 2 to the 5th power, that would be 32. So the fifth root of negative 32 must be negative 2. And then if we cube that, we'll get negative 8. So negative 32 to the 3/5 power must be -8. A few more examples. 64 to the 3 halves. Let's think about it. Half means square root, so the square root of 64, 8. 8 cubed. Ooh. Yikes. What is 8 cubed? 8 times 8 times 8. 8 cubed. So that would be 64 times 8. 512. Okay, this one's tricky. 16y to the -8 all to the 3/4 power. Okay, first of all, let's maybe rewrite this so that we don't have any negative exponents. So let's maybe say 16 divided by y to the 8th. And then this 4 in the denominator tells us we're going to do a 4th root. And then this 3 in the numerator tells us we can take all of that and cube it. Okay? Let's see, the 4th root of 16 is 2. The 4th root of y to the 8 would be y squared. That's what we're cubing, which must give us 8y to the 6th. 8 over y to the 6th would be 16y to the -8 to the 3/4 power. So you can kind of see why they're called rational exponents. It's because all of these fractions are rational numbers. We've only talked really about integer exponents up until this point. But you can have fractional exponents as well. Okay, I think that ought to do it. I'm going to just post the accompanying homework assignment. We'll regroup on Friday. Have a good e-learning day.